Welcome back. As we said in the last lesson, we are going in this lesson to see how we can perform exploratory data analysis on the adult dataset. So let's first start by importing the needed libraries. Of course, we will import the main libraries, which are matplotlib, pandas, numpy, cporn, and here we are also importing from scipy, and this is short for sciencepy. We are going to import stats, and you will see when we are going to use it. And we are going to import also two math functions, which are log2 and square root. Okay, and then these are the functions or the modules we are going to import from sklearn, right? So train test split, label encoder, decision tree classifier, metrics tree, pre-processing, and export graph-viz. And this will be used when we are going to visualize the tree, and grid search for hyperparameter tuning. Okay, and we will also import some extra libraries. So as you can see here, we are going to import from a library called 6, we are importing string.io, and from IPython we are going to import image, and we are going to import py.plus, and from Taqaddum we are going to import Taqaddum notebook as Taqaddum. And we will see why we need these libraries in due time. Okay, so let's start by performing exploratory data analysis. And as we said, we are going to use a very famous dataset called Adult Dataset, and the objective of this dataset is to predict whether income exceeds $50,000 per year based on CNAS data. Okay, so we will use the decision tree algorithm to predict if an individual earns more than 50K annually and is therefore eligible for new credit card. So if we go here, you will see that this dataset is not actually in sklearn. So in order to use dataset, we are going to go to machine learning repository, and this is from UCI, okay, Center for Machine Learning and Intelligent Systems. And as you can see here, you can download the data folder and you can download the dataset description folder. So this is an abstract about the dataset, just like what we said. And here you can see that the dataset characteristics is multivariate. So we have more than one variable, and we have categorical and integer attributes. And this dataset is actually used for classification, not regression. The number of instances we have in this dataset is more than 48,000. And as you can see, we have missing values in our dataset, and the area of this dataset is for social. So for example, we can use it to predict if this person is going to donate to a charity or not. So we can use this information or this prediction for many social activities or for many social projects. Okay, and this data was donated in 1996, so 24 years ago or 25 years ago, and more than 2 million people accessed this dataset. So as we said, it's a very, very famous dataset. Okay, here we have more information about the attributes and the papers who published this dataset and the papers that cited this dataset. So as you can see, there is a lot of papers who cited this dataset. And here, in order to download the dataset, we will go to the data folder, and here we have index, adult.data, adult.names, adult.test, old.adult.names. So we are going to download adult.data and adult.test. Okay, and let's also download adult.names. So if you try to open the files right now, you will see that we have an error because this extension .names is not actually recognized by any operating system. So how we can open these files? This can be a little bit trivial, but if you don't know it, then you might have some problems. So we will go to the folder where these files are downloaded. So let's go. So here we are. In order to open these files, we are going to rename the file, right? So let's call it adult_test, for example, and then .csv, right? Comma separated values. So you will see here we have, if you change a file name extension, the file might become unusable. Are you sure you want to change it? Yes. So now, as you can see, we can open it in Microsoft Office, for example, or actually any software that opens comma separated values. And as we can see here, we have the first row. We have here 1 times 3 cross validator, and then we have some empty cells. And for each row, we have a person, right? So here we have private, and then this is a number. We don't really know yet what is this number used for. And here we have 11, 7, never married, own child, black, male, 0040, United States, and less than 50k. Okay, so each row corresponds to an individual or corresponds to one example. Let's go to the other files. So we need to rename this also. So here we name it, we open it, you will see this data was extracted from CNS Bureau dataset found at, and so on, right? So some information about the dataset and the accuracy we can get using each algorithm. Okay, so this file is not that important, but if you want to know more information or get more insights on this dataset, you might find this file useful. So let's go to the last file here. Let's try to open it. So we will call it CSV. Right now, if we open it, you will see that for each row we have also an individual, but this is the training data. So you can see here we have 32,561 instances or examples, and in the test data we have 16,281, so a total of more than 40,000 as we saw on the website. Okay, so what we are going to do, we are going to use this test file for testing and use the other file for training and validation. And we are going to get the names using the names file or from the website itself, because we know from the website that the first column corresponds to X feature, and here this corresponds to Y feature, Z feature, and so on, right? So we know what each column represents. So we will name the columns in pandas, but first, after you download the data, you need to rename the files to be accessible or to be readable on your machine. So let's go to the code. So here we are. This is the dataset attributes. First we have the age, and this is a continuous variable. We have the work class. We have something called FNLWG. We don't really know what is this, right? You can read more on the website if you want to know more details about this variable, but it doesn't really matter at this moment. We have the education, and we have the educational number. So you might have noticed that there might be some kind of relationship or correlation between education and educational number, and this is actually true, and this is what we are going to see in the project, right? We are going to see what are the redundant features that we don't really need or we can drop, right? And then we have occupation, relationship, race, sex, capital gain, capital loss, hours per week, and native country. And as you see, we have some of them are continuous variables and some of them are categorical variables, right? So you need to know that our implementation for the decision tree will work with both the continuous and the categorical variables. The sklearn implementation has some problems, so we need to encode the data, but we don't really need to worry about this at the moment. So let's load the dataset. We are going to load the dataset using pandas, of course, using the read CSV file, right? And if we try to do so, we will have a problem, right? Because we don't really have the dataset in Colab, right? So what I have done is that I came here and upload files, and then you upload the data into your session, right? But if you close the session, so if you don't have internet connection, or if you left the session open for a long time without any activity, then you need to load the datasets again and load all the files again. So this is not a persistent memory. It's not a memory storage that you can use anytime. Now, after we do so, after we load the data, as you might have noticed, we have a problem here because the columns names are not correct, right? Because as you saw, when we opened the Excel sheet, we had in the very first row, we had this one, right? We had this example. So pandas by default will look at the first row and infer that this is actually the columns, because in most cases this is true, but here this is not true. So how we can fix this problem? We can come here and write header equal none, right? So if we do so, you will see that the dataset is actually loaded correctly. Okay, now we have another problem, right? The columns names, although they are not the first example, they are still not representing what this data is about, right? What this column represent, or what this column represent, and so on. Okay, so what we are going to do is that we are going to create a list that contains the columns names, right? So here I have it. So as you can see, the columns names are age, work class, FNLWG, education, educational number, and so on, right? So we got this from the other file, right? From the adult_names. So now how we can overwrite these values, right? Because if we run the code, we didn't really change anything here, right? So we can do it in two ways. The first way is that we can come here after we load the dataset and write data.columns, right? And then we will choose, or we will assign the columns names, right? So if we do so, you will see that the columns names are now overridden or are now correct, right? Educational number is correct, occupation is correct, everything is correct. Okay, the other way around, right, is when you are loading the dataset, right? Because here we loaded the dataset first, and after that we changed the columns names. But if we want to do this from the very beginning, we can come here when we are loading or reading the CSV file and write names equal columns names. Okay, so if we do so, you will see that we have the same result. We have the dataset loaded with the correct names. Okay, so this is actually very simple. Now, if we describe the dataset using the describe function, as you can see, we have the age, the educational number, the capital gain, the capital loss, and hours per week. Although we had here 15 variables, right? 15 features or columns, we have here only 1, 2, 3, 4, 5, 6 variables. Why? Because we cannot really describe the categorical variables. We can only describe the numerical variables. We can describe the categorical variables if we encode them and convert them to numerical variables. But if they are still categorical variables, we cannot really describe them or have some statistics about them, right? So here we have the count. So if you notice, we have the dataset completed. We don't really have any missing values, but we might have corrupted values or wrong values, right? So we need to dig deeper into the dataset and understand what are the problems in this dataset that need fixing, so we can get better and better results. But we won't really care about this at the moment. We won't really care about normalization and feature scaling and so on. We will try to keep the data as it is for now, and after we implement and after we understand everything about the decision tree, we will go to the project and try to do every single thing on the dataset, right? So we'll disassemble the dataset and perform all the necessary pre-processing and visualization. But for now, we are exploring the dataset in a very, very native and very simple way, right? Now, if we use the info function also, you will see that we have the age, work class, and so on. And as you can see, the data type for each variable, right? So we have here the age is integer, we have the educational is object, we have the educational number integer, and so on, right? So it's correct. Now after that, we can print the dataset shape. So as you can see, we have more than 32,000 examples and we have 15 columns. Of course, the final column is the target column or the label column. And here we can see what are the categorical and what are the numerical variables we have using the info function. We have just done this here, right? So we have 6 of them are integer and 9 of them are categorical or object. So now let's perform some very, very basic data exploration by just plotting the count plot, right? So we will plot this count plot to understand if the dataset is balanced or not. So what do we mean exactly by balanced? It means all the classes are equally distributed or equally represented, right? Because if we have a dataset that contains 100 examples and 95 of them are 1 and only 5 of them are 0, then this dataset is not balanced. So what is the problem that might happen if we have something like this? Basically, if we have a machine learning model that doesn't really do anything other than just printing 1 or just predicting 1 each time. In this case, we will have a prediction of 95%, right? We will have a 95% accuracy. Although our model is not actually doing anything at all. It's just printing 1, 1, 1 or predicting 1, 1, 1 each time. So we need first to know if the dataset is balanced or not. If it's balanced, then that's fantastic and we can use the accuracy with no problems. But if the dataset is not balanced, then we might need to choose another metric than the accuracy, or we might need to consider this when we are working on the loss function, for example, or when we are working in the algorithm itself or choosing the algorithm itself. So this question is very, very important when you are working on any machine learning project. So let's run this. You will see that we have inside cporn a function called countPlot, and this basically will return, as you can see, show the counts of observations in each categorical bin using pores, right? So the X is target, right? This is the column name, and the data frame is called data, right? So if we run this, as you can see, the dataset is not balanced. So we have around 25,000 are less than or equal 50k, and around 6,000 or 7,000 are more than 50k. So the dataset is not actually balanced or well distributed. Okay, so in the next lesson we will understand what do you mean exactly by decision tree, and we will start implementing the decision tree from scratch. So let's go.